Alrighty, so in this video, we're going to be talking about some quadratics or these parabolas, and we're going to be taking these factored form binomials, and we're going to go ahead and turn them into trinomials by just kind of using some algebra. And basically in this form is going to be called standard form. Once we do that, we're going to go ahead and write these coordinates of a few different things here. One of the first things we're going to do is find the x-intercept. So I'm going to put that in green here. That's basically going to be where is this graph going to be crossing the x-axis. And then following, we're going to go ahead and find the y-intercept, and that's going to be where the graph crosses the y-axis. And then finally, we're going to find the vertex, or the highest or lowest point of a quadratic. Okay, in this case, I think all these examples, it's going to be the minimum or the lowest point. All right, so jumping right into it for this first one, what we're going to do is we're going to go ahead and FOIL. So we're going to multiply this x times this x, and we're going to multiply this x times this 1. If we do that, x times x is going to be x squared, and then x times 1 is going to be a positive 1x. And then we're going to distribute this 3 to the x and then this 3 to the 1. And so we're going to get 3x, and then we're going to get a positive 1. Okay. In the middle here, we're going to notice that we can combine some like terms. So I'm going to go ahead and notice in the middle that these are like terms. And so we can combine those and say that y is equal to x squared plus 4x plus 1. So this right here would be the trinomial form of this, this quadratic, okay? We basically turn it from factored form into this standard form, okay? It's a trinomial. Now, the next thing we're going to do is we're going to see if we can find the x-intercept. So the x-intercepts are pretty straightforward. I'll go ahead and write x-intercepts. And what you have to do is find out basically when each of the binomials are equal to 0. So when is this first one equal to 0? It's when x is equal to -3. So if x is -3, then the whole thing on the right side becomes 0, okay? There's going to be another one here. When does the second binomial equal 0? And that's when x equals -1. So if x is -1, then the whole second binomial becomes 0, and then the whole right side of the equation becomes 0, so y is 0. Okay. Following that, we can find the y-intercept. So the x-intercepts are easy to find out in factored form, but the y-intercept is basically just when is the, if x is 0, what does y become? So if x is 0 in this trinomial, that's why this form is a little bit more useful. If x is 0, then everything cancels out except for the 1. So we can go ahead and say that when x is 0, then y would equal 1. And so that would be the y-intercept. Okay. Finally, what we're going to have to do here is find the vertex. And so the vertex is a little bit more tricky. I'll go ahead and just write that down first, the vertex right over here, and see if we can figure this out. Now, it's important to remember that these parabolas, or the shapes of these graphs, are always going to be symmetrical. So if we find out where the two x-intercepts are, then the middle of it, or the vertex, is always going to be equidistant from them, right? So our x-intercepts are -3 and -1, and so you can either find the average of them or the midpoint between those. And halfway between -1 and -3 is going to be -2. So I know that -2 is going to be the x-coordinate for the vertex. And to figure out how high or how low the vertex is going to be, you can plug in this -2 into either this factored form above here to find out what the y value is, or you can plug it in right over here to standard form. Either one's going to be okay, and it'll help us find out where the y value is for the vertex is going to be. For the purposes of this one, I'm going to plug it into the first one. So if I plug in -2 into the first binomial, then -2 plus 3 is going to be 1. And then -2 plus 1 is going to be -1. So if we multiply those out, y would equal -1. So for the vertex, we will get -2 comma -1. Okay, so this would be the vertex as well as the y-intercept as well as the x-intercepts for this parabola. All right, let's check out number 2. So for number 2, we're going to do something very similar. So we'll go ahead and take this, and let's go ahead and distribute. So this x times this x, and this x times this 9, so x times x is going to be x squared. X times 9 is going to be 9x. Then 5 times x is going to be 5x, and 5 times 9 is going to be 45. So I'm going to add 5x and then add 45. Then we're going to go ahead and combine those like terms in the middle. And so we're going to get y is equal to x squared plus 14x plus 45. All right, so that would be the quadratic written in trinomial form, okay, or in standard form, as we can say. We'll talk more about that in another video, but that's what we need to get started. And then we have our 3 things that we need to figure out here. So for the x-intercepts, let's figure out when the binomial is equal 0. So at -5, you will make the whole right side equal 0. And for the second one here, if x was -9, then the whole function would become 0. So factored form is good for that. Because we went ahead and found the standard form of the trinomial, we actually know that this parabola is going to cross the y-axis at 0, 45. Again, if x was 0, then the whole right side cancels out except for the 45. Finally, for the vertex, remember it is going to be halfway between the two x-intercepts. So what number is halfway between -5 and -9? That's going to be -7. Okay, and we can use that number to figure out how high or how low that's going to be. Again, you can use standard, you can use the factored form here, or the the trinomial or standard form. Again, my preference is to use the factored form here. So I'm going to say y is equal to, we're looking for that, -7 plus 5 is going to be -2. Inside the first binomial, the -7 plus 9 is going to equal +2. And so -2 times 2 is going to be -4. And so -4 will be the height of the vertex. Okay, so there you have the vertex -7, -4. All right, let's check out number 3 here. So for number 3, we're going to start off by writing y equals again. Okay, and we'll go ahead and FOIL this out. So multiply x times x, and then multiply this x times 7. So first we're going to get x squared, and then we're going to get 7x, and then distributing this -3 to each of these, we're going to get a -3x and then a -21. And then we can combine those like terms of this +7 minus 3. So we're going to get y is equal to x squared plus 4x minus 21. So that's the trinomial right there. Okay. Going ahead and figuring out some more information. So for the x-intercepts, we have 3. That makes this one 0. So if x was 3, then y would become 0. And then for the second binomial, if x was -7, then y would become 0 as well. Okay. Taking a look at the trinomial, if x was 0, then y would equal -21. So that's where it would cross the y-axis. And then in terms of the vertex, let's see, what's halfway between 3 and -7? Well, they are 10 apart from each other, so in the middle has to be 5 away. So 5 less than 3 would be -2. And that's also 5 more than -7, so we know it's going to be -2 comma something. And again, my preference is just to kind of plug it in over here, so let's figure out the y value here. So -2 minus 3 would be -5, and then -2 plus 7 would be +5, so that would be y is equal to -25. That would be how low or how high the vertex is. Alrighty, for number 4, let's check this one out. So we'll start off by distributing this x times x, which is x squared, and then x times 3, which is going to be 3x. So we'll have x squared plus 3x. Okay, then we can multiply this +3 by x, which is 3x again, and then 3 times 3 is 9. So we have another 3x in the middle. And you're going to notice that's always going to happen when you have two identical binomials. You'll get two terms in the middle that are the same, so they'll always double up. So it'll be x squared plus 6x and then plus 9. So there's our trinomial. And so let's go ahead and just kind of copy this down here. And so where are the x-intercepts? Well, notice that -3 makes this become 0, but also that's the same thing. So -3, if x is -3, then y would be 0, but there's only going to be one x-intercept here if the binomials are identical. Okay, for the y-intercept, that's going to be when x is 0. So when x is 0, you do get y is equal to 9. Okay, so that's going to be nice for our y-intercept. And then for our vertex, this is actually pretty interesting that only, if we have to find halfway between the two x-intercepts, if we only have one x-intercept, then that is where the vertex is going to be located. Hopefully that makes sense. I can go ahead and throw this in Desmos to see visually what this looks like, but the x-intercept is actually the same thing as the vertex, and you'll see why, because I'm going to plug in that -3 here. So if I plug in -3 in for this first binomial, -3 plus 3, that's going to be equal 0. And then -3 plus 3 is 0. So when x is -3, y equals 0. But that's the same thing as what the x-intercept was anyway. So yeah, that's basically what's gonna happen if you have two of the same binomials. All right, let's check out number 5 here. Oops, I can scroll up just a little bit more. For number 5, this one's actually kind of interesting too to take a look at. You'll get used to these patterns as you see them more and more, but x times x is going to be x squared, and then x times 5 is going to be 5x, so we're going to have x squared plus 5x. But look what happens here, this negative 5 times x and this negative 5 times the positive 5, we're going to get a minus 5x, and then we're going to get a minus 25, right? And so the binomials are really similar looking. One has a plus, one has a minus. So notice what happens in the middle here. You actually get opposites. So we're going to get y equals x squared minus 25, right? So those middle two terms actually cancel each other out because they have opposite coefficients, okay? So let's go ahead and see if we can figure out some stuff going on here. For the x-intercepts, there's two numbers that make this become 0. For the first one, it's going to be positive 5, then the whole thing becomes 0. If x is negative 5, then the whole thing becomes 0. For the y-intercept, looking at standard form, this constant here, if x is equal to 0, then y would equal negative 25. So that would be equal to the y-intercept, okay? And then for the vertex, if you go halfway between these two x-intercepts of 5 and negative 5, well, they're 10 apart, so halfway between them actually is 0, and that's always going to happen if you have opposites. And so 0, comma, and let's see what's going to happen here. So I think I'll go over something interesting that we can talk about here as well. If you plug in 0 in for x, then 0 minus 5 would be negative 5, and then 0 plus 5 would be positive 5, y equals negative 25. But if you take a look, that's actually the same as the y-intercept, right? So notice what happened in number 4. In number 4, if we look closely, we can see that the vertex here was identical to the x-intercepts, and that was because you had two identical binomials. And if you take a look in this one, our vertex of 0, comma, negative 25 matches our y-intercept, and that happened because our binomials are actually almost identical, just one has a plus and one has a minus. So let's try to take a look at that pattern in the future and see if we can notice that to help save us some time and just to notice some patterns going forward. All right, let's take a look at number 6. So for number 6, let's go ahead and give this one a try. We have y equals, we can distribute this x to this x and then this x to this 1. And if we do that, we're going to get x squared plus 1x. And then we can distribute this minus 4 here to both of these. We'll get minus 4x minus 4. We can combine these like terms in the middle, this positive 1 minus 4. So it'll be y is equal to x squared minus 3x minus 4. Okay, that's going to be our trinomial. And if we go ahead and see if we can find out some additional information, if x was 4, then this whole thing would become 0. And if x was negative 1, then the whole thing becomes 0, okay? For the y-intercept, that's when x is 0. So when x is 0, we just left with this constant. So we'd get 0, comma, negative 4. And for the vertex, let's see if we can figure out what is halfway between the two x-intercepts. So what is between 4 and negative 1? Well, they are 5 apart, and half of 5 is 2.5. So if you go 2.5 under 4, that's 1.5. And that's also 2.5 away from negative 1. So let's go ahead and say that's going to be 1.5 or 3 over 2. Fractions are just a little bit easier to work with, I think. And so if we take 3 over 2, and we have to go ahead and plug it into either this factored form here, or we can plug it into this standard form here. And I don't think I've tried using standard form yet, so I'll go ahead and show you that. So y would equal 3 over 2 squared minus 3 times 3 over 1 times 3 over 2, and then minus 4. So 3 over 2 squared would be 9 over 4 minus, and then this is going to be 9 over 2. And I'm just going to write this as 4 over 1 for a moment. This is going to be 9 over 4, and then common denominators is going to be 18 over 4, and then common denominator is going to be 16 over 4. And so 9 minus 18 is negative 9, and negative 9 take away 16 is going to be negative 25 quarters. So negative 25 quarters, and it's important to know that leaving these in improper fractions is perfectly fine, probably more preferred than using decimals. All right, for number 7, let's go ahead and do the same thing. See if you can follow along here if I do a little less talking. Go ahead and combine those like terms. There's our trinomial. For our x-intercepts, take a look at the binomials, see what makes them equal 0. For the y-intercept, take a look at the constant term, or when x is equal to 0. And for the vertex, look in between these. These are 8 apart, so 4 is halfway, so 4 less than 3 is -1. And we can use this to go ahead and find out our y value. I'll use standard form again just to give it some practice. So the y value is going to be -16. All right, let's try number 8. Same thing, let's give it another go. If you want to try it on your own, feel free to give it a go. But I'm just going to do the same process here, see if we're getting a little bit better with the process. For the x-intercepts, look at these binomials, see what makes them equal 0, which will be -4, and will be +2. For the y-intercept, we have the c value here, or the constant, so when x is 0, we find out that y is -8. And for the vertex, these are 6 apart, so half of 6 is 3, so 3 more than -4 is going to be -1. And let's see if we can figure out where y will be. So I'm going to actually use the factored form. So -1 plus 4 is going to be +3. -1 minus 2 is -3. Y equals -9. That'll be the vertex. All right, let's try number 9 here. Remember, for this one, we're only going to have one x-intercept because the binomials were identical. And remember from earlier when this had happened, halfway between -6 and -6 is still just -6. And if x goes in for -6, then y should still equal 0, so you don't have to think too much about that. Let's try one last one on this page here, number 10. X-intercepts here will be 5, 0 and +1, 0. Okay. For the y-intercept, that will be 0, +5. And for the vertex, let's see, we have to go halfway between 5 and 1. They are 4 apart, so 2 more than 1 would be 3. So when x is 3, let's go ahead and plug it into here. So let's see what y would equal. Well, 3 minus 5 would be -2, and 3 minus 1 would be +2. And so that would equal -4. So 3, -4 would be the vertex for this parabola. Alrighty, halfway there. Let's try a few more. trinomial here will be y is equal to x squared minus 4x minus 21. And from this, we can go ahead and find out some more information. Take a look at the binomials. Our x-intercepts are going to be -3, 0 and +7, 0. For our y-intercept here, that's going to be when x is 0, we'll find out that y will be equal to -21. And for the vertex, let's figure out halfway between these. Well, these numbers are 10 apart, so half of 10 is 5, and 5 less than 7 is going to be 2, so 2, something. And I like plugging it into this top one in the factored form, so 2 plus 3 is going to be 5, and then 2 minus 7 is -5, and so if you multiply those, we're going to get -25. That would be the vertex for this parabola. Here's number 12. Combining like terms, our trinomial will be y is equal to x squared plus 2x and then -8. There's our trinomial. And we'll go ahead and see if we can find out the intercepts here. So from these two binomials, we have -4, 0, and then we have 2, 0. For the y-intercept, that's this number here. So when x is 0, we'll find out y is -8. And for the vertex, halfway between -4 and 2, well, they are 6 away from each other, so half of 6 is 3, so 3 less than 2 would be -1. So -1, something. I'm going to plug it into the factored form. That's just my preference, so -1 plus 4 is 3, then -1 minus 2 is -3. So when x is 1, y would equal -9. So that would be the vertex here. All right, let's try 13. So for 13, we'll start with y equals and go ahead and distribute. Combine those like terms. We'll get y is equal to x squared plus 8x, then -9. Terms of these pieces now, the factored form is more useful for the x-intercepts. That's going to be 1, 0 and -9, 0. And then for the y-intercepts, that's more useful when looking at standard forms. That's going to be 0, -9. Then for the vertex, let's figure out where the middle is. So they're 10 apart. Half of that is 5. So 5 higher than -9 would be -4, which is also 5 lower than 1. And we're going to go ahead. Well, I'm going to go ahead and plug it in here. So when x is -4, we will get -5 here and +5. When x is -4, y will equal -25. That'll be where the vertex is. For 14, check out this pattern. We've seen this before. See if you can notice it or recognize it. If you notice it, that's awesome. These middle ones will always cancel out with each other. So we're going to just have x squared minus 16. As for the pieces here, we're going to get 2 of these that are opposite. So -4 makes the whole thing equal 0, and +4 makes the whole thing 0. And for the y-intercept, when x is 0, we find out that y is equal to -16. So that's that right there. And then for the vertex, well, halfway between these two numbers is going to be 0. And if x is 0, then we could actually plug it in right over here, right? So 0 squared is 0 minus 16. So if you notice the pattern from earlier, that when you do have these opposite x-intercepts, that the vertex's location is the same location as the y-intercept. All right, so let's check out number 15 here. For 15, we have y equals, distribute all of this, or FOIL, however you want to think about it. Go ahead and combine these. When x is negative 9, y will be 0, and when x is positive 5, y will also be 0. For the y-intercept, when x is 0, y will be negative 45. And for the vertex, okay, these are 14 apart from each other. Half of that is 7, so 7 less than 5 is negative 2. And if we plug it in over here, let's see, negative 2 plus 9 is going to be 7, and then negative 2 minus 5 is going to be negative 7. That's going to be negative 49. So when x is negative 2, y will be negative 49. Alrighty, 5 more to go. Let's check out number 16. These will be the two x-intercepts. This will be the one y-intercept. And for the vertex, I'm going to plug in this 5, which was the x-coordinate for it. This will be 1, negative 1. So 5 comma negative 1 would be the vertex. Let's try 17. One x-intercept will be negative 3 comma 0, and the other one will be negative 9 comma 0. In terms of the y-intercept, we will have 0 comma positive 27. For the vertex, this negative 3 and negative 9 are 6 away, so half of 6 is 3. So it's got to be 3 away from each, so I think negative 6 would do the trick. And if we plug that in to find how high or how low for the y value, negative 6 plus 3 is negative 3 times a positive 3. So y would equal negative 9 when x is negative 6. So that should be the vertex. Let's check out number 18. See if you can give it a go on your own from beginning to end if you're feeling pretty good about it. So there's everything I got for number 18. Hopefully you got the same. Last couple here. Now, number 19 was a little bit more tricky just because there was an odd distance between the two x-intercepts. So between -3 and +8, they were 11 apart. So half of that was 5.5 in terms of the distance away from them. So when that happens, it is a little bit messier. So just keep that in mind. It is very normal though, that they're not always going to be even. I tried to keep it even for most of the practice problems here, but I thought it made sense to at least show maybe one or two examples where it didn't. So that was an example there. And if you did do well with that one, then fantastic job, because it's definitely a little bit more tricky. And here's one more. These are, they have x-intercepts that are even distance again apart from each other. So it's probably not as bad. Alrighty, so see how you did with number 20 as well. And if you got these x-intercepts and y-intercept and vertex, then you did a fantastic job. Another thing you could do if you wanted to check these visually is feel free to go on to using a graphing calculator or maybe like a Desmos free calculator online. Type in any of these functions into those calculators. Desmos is probably the easiest one, Desmos graphing. And you could check to see visually if these do actually work out, right? And you can actually plug them in, and then you can click on the graph at the x-intercepts and the y-intercepts and the vertex, and it should tell you, and these should all match up perfectly. So if you feel a little bit more confident with these quadratics, especially finding these important types of locations of the functions, then fantastic work. And as always, keep up the great work, and I'll see you in the next one.